Hello fellas, and welcome back to the channel. I'd like to thank everybody for watching and all the new subscribers. It really means everything. Alright boys, I want to do something a little bit different today, and I want to kind of brush through the NEC code book. And today we're going to be off the clock, but we're still going to be working, because as a trainee electrician, you're always going to be learning. Even as a C10 contractor or a journey worker electrician master, you're always going to be learning. Every situation is absolutely different. So by knowing the code book, it's going to do you a lot of help in the field. And the only way to learn the code book is to be in the code book. So I want to go over some code questions that were given to me by a channel called Mastering the NEC. And the teacher who teaches that channel and that course, his name is Paul Abernathy. If you ever have time, go ahead and check him out, man. He's really good. He's really helpful. So you can actually watch that channel and mine and get a lot of information out of it. You know, we all strive to be the best, and we all try to do the best installs or repairs that we can with the knowledge that we have. That's why an evolving person, always training and looking to learn more, is always the best option, because what it all comes down to at the end of the day is going home safe and not burning up somebody's equipment or making a huge mistake that you have to go back and correct, which costs money. So being cost effective and efficient, and also doing the proper installation or proper repair is very important in this field. Anyways, by using the NEC and staying in the NEC and answering questions from the NEC, it just makes you a better overall worker. So this is actually, I'm going to go over one of the questions that I did and I actually got wrong through Paul's course. And the question was, what load in kVA shall be added to the service for an office building with 200 receptacles? And to answer that, we're going to have to go into the NEC code book. So let me go ahead and pull that up, and I'm going to pull up the code book. So there it is. So there's the code book, and this code book that I'm actually showing you guys, this is the free access from the NFPA website. So anybody can go there and you can actually utilize the most up-to-date code book for yourself in order to help yourself train if you can't afford a code book, which I know they're pretty expensive. So let's go ahead and head to the code section that we're going to be working out of, and that will be chapter 2, wiring and protections. In this chapter is going to be the article that we're looking for, and I'm just trying to save some time for the sake of this video. So it's up to every individual himself to kind of brush through the code book and kind of get familiar with how to navigate that thing. So right now we're in general. So if you kind of just breeze through all the chapters here in the free access code book, we're going to be right here in chapter 2. Aside from that, if you look at the article 220, branch circuit feeder and service load calculations. So if we go ahead and open that bad boy up, let's go ahead and click that. So this article 210 is branch circuits not over 1,000 volts, but the question was branch circuits. It talked about a service load calculation. So we're gonna go ahead and be in here, and I like to start out at the first article. Start out in part 1, general, because if you look in general, it's gonna basically give you a layout of the chapter, so you can pick through those boxes and see what you're going to be looking for. So part 2 will be branch circuit and load calculations. So if we look at part 2, branch circuit and load calculations, the general of part 2 will kind of tell you what's involved in this article or this part of this chapter. So if you look at the first headings, 220.10 general will give you number 1, 220.14, all other load occupancies, and that is right here. So if you read through them, just for the sake of time, I'm not really going to read through them, but we're looking for all other loads, all occupancies. So that's going to be 220.14. So I'm going to head over to 220.14, which is right here. Other loads, all occupancies. It says branch circuit load calculations shall include calculations of a minimum load on each outlet as calculated in 220.14a through k, and then summed to establish the load on the branch circuit. So basically we're going to be looking through 220.14a through k. So the section that we're looking for is 220.14i, receptacle outlets. And here is that code section right here, 220.14i, receptacle outlets. Except as covered in 220.41 and 220.14j, receptacle outlets shall be calculated at not less than 180 VA for each single or for each multiple receptacle on one yoke. So that will be basically like a simplex or a duplex, or two single receptacle plugs on one yoke. The yoke is the strap that mounts to your gang box. A single piece of equipment consisting of a multiple receptacle comprised of 4 or more receptacles shall be calculated at not less than 90 volt amp. So this isn't one of those multi-recep deals that we're talking about. We're just talking about either a duplex or a quad boxes on the wall for some offices. So we kind of wouldn't have to worry about that second part. And then we look at J, 220.14J, which says receptacle outlets in office buildings. In office buildings, the receptacle loads shall be calculated to be the larger of the following: the calculated load from 220.14i, or 11 volt amperes, which is 1 volt ampere per square foot, which is our load. 180 volt amperes for each single or multiple receptacle is definitely higher than option 2. So we're definitely going to go with option 1, and this is what the calculation is basically going to look like. It's basically going to be 200 receptacles at 180 VA per receptacle, which comes out to 36,000 volt amperes, or 36,000 VA. So we've already used 220.14J, receptacle outlets in office buildings. So we kind of seen that, and we got to see number 1 and 2, which one is higher of the two. So that has already been done and calculated, and it came out to the same thing, 36,000 VA. So where I calculated this question and where I got it wrong was, this is kind of where I left it, and I left it at 36,000 VA, or 36 kVA, but I didn't push further when it asked the question, and that's how I got it wrong. So by doing the code and by utilizing the code, I was able to expand my knowledge, because then it goes on to say part 3, feeder and service load calculations. And if you utilize this part and this article, 220.43 office buildings, it says in office buildings the receptacle loads shall be calculated to be larger of the following: the calculated load from 220.14i after table 220.47, demand factors have been applied. And that's kind of what I left out. And if you were to be taking your journeyman exam, you're definitely going to get this question wrong. This is why I am pushing myself to go through these questions, and I might as well put it on video so that maybe more than just myself will get something out of it. So it says table 220.47, and this article is 220.43 office buildings, and it's going to tell us to go to 220.47. So let's go ahead and head over there. Let me jump over the next page. 220.45, 220.47. So table 220.47, demand factors for non-dwelling receptacle loads. And that's basically what it is. Receptacle loads other than dwelling units. So 220.47 says receptacle loads calculated in accordance with 220.14H and I shall be permitted to be made subject to the demand factors given in table 220.45 or 220.47, and it's the 47, which is this table right here, that's where we're going to be at. And this is kind of where I got that question wrong. So this table 220.47, demand factors for non-dwelling receptacle loads, it says for the first 10,000 kVA or less at 100% demand factors. So that's how I got that question wrong. I did not include the demand factor on that. And then it said the remainder over 10 kVA at 50% demand factor. So that's kind of the simple math that I didn't apply to the question because I just didn't know. So you have to get familiar with these code books and these sections and all the tables in the NEC so that you can be on point when it comes to this stuff. So this is basically what the question came out to. So we started out with 200 receptacles and we multiplied that by 180 VA per receptacle, and that came out to 36,000 VA. So if we were to do table 220.47 demand factors, we would see that for the first 10,000 kVA or less would be at 100%, and that's right here where we are. The first 10,000 at 100%. Then it says the remaining at 50%. Basically the remainder at 50%, and this is what the math comes out to. So the first 10,000 would be 10,000 VA. The remaining at 50% would come out to 13,000 VA. So then it just comes an addition problem. 13,000 VA plus 10,000 VA would equal 23,000 VA. You divide that by 1,000. Now you got 23K VA. And that's kind of how simple it could be. And that is the problem that I actually got wrong, which is fairly simple, but I did not read enough of that section, that code section, to get familiar with the entire chapter. So I didn't see what I left out that was included in part 3. So anyways, these are the kind of things that if you are in the trades, you're gonna have to look out for, and there's a lot to it. There's a lot of learning involved. So my tip for everyone would be keep your head in the code book, and any chance you get, go over chapters, always test yourself and always challenge yourself and train yourself. And anytime you're doing little installations or whatever it may be, residential, industrial, commercial, definitely always think about what you're doing and try to apply code in your mind as you're doing the job, and try to regurgitate code sections to yourself. I know it's very boring, but it will make you a better trainee or a better electrician, whatever category you fall under. So I really want to thank everybody for watching, and I really appreciate it. And if you have not yet subscribed, go ahead and smash that subscribe button, and you might as well hit the like because they're right next to each other. I really appreciate it, boys. I will see y'all later. Stay safe out there.